Hello, respected Darshan sir. I'm myself Suraj Desai and my teammates Bipul Gupta and Yash Jain are here to present our mini project on the topic logical regression using the data set which is UCI Adult Income. So basically, I will first talk about logistic regression. So logistic regression is used when the dependent variable target is statistical. For example, if we are predicting whether an email is spam or not, so like ones or zeros, or whether a tumor is malignant or not, again ones or zeros. So basically, what I mean to say is their value strictly ranges from 0 to 1. Now let's consider a scenario where we need to classify the email as spam or not. So if we use linear regression for this problem, there is a need for setting up a threshold based on which classification can be done. Say if the actual class is malignant, predicted continuous value 0.4 and the threshold value 0.5, the point will be classified as not malignant, which can lead to serious consequence in real time. So from this example, we can conclude that linear regression is not suitable for classification problems. Now I will discuss the types of linear logistic regressions. So there are three types: binary logistic regression, which is categorical response has only two possible outcomes, say spam or not. Then there is multinomial logistic regression. So three or more categories can be obtained without ordering. Example, prediction which food is preferred more, like veg, non-veg, or vegan. Then there is ordinal logistic regression, which is three or more categories with ordering. Example, movie rating from 1 to 5. Now I will discuss why we should use logistic regression. So predictive models built using this approach can make a positive difference in our business or organizations, because these models help us understand relationship between prediction of outcomes and then improve our decision making in the process. So like for example, manufacturers analytics team can use logistic regression analysis as part of a statistics software package to discover a probability between failures in machines and the length of those parts which are held in inventory. Now, I will also discuss some advantages of logistic regression over linear regression so that we can understand why using logistic regression is a better approach for our project. So, linear regression and logistic regression are both supervised machine learning algorithms. Linear regression and logistic regression both are models that are parametric regression. That is, both the models use linear equations for their predictions. Then linear regression is used to handle regression problems, whereas logistic regression is used to handle classification problems. And linear regression provides continuous output, whereas logistic regression provides a discrete output. So we can see that there are a lot of advantages of logistic regression, and hence we are using the same. Now I will talk about the data set. So I will take us to the data set. So this is our data set, and I will just give you an overview. Right, the data set has 15 columns like age, work class, education, marital status, occupation, relationship, etc. So based on all these factors, we are here to basically predict the salary class of a person based on the given information using logistic regression model, which is the log model in our case. So now now we have four main tasks in our project, which is reading the data, then cleaning the data, then exploratory data analysis, which will include plotting of graphs, and in the end, building the logistic regression model, which will help us predict the salary classes of people. So from the structure output, right, the output from the structure of the data set, we can see that some of these columns have a large number of factors. Now, in order to clean these columns, we are combining similar factors, thus reducing the total number of factors and hence reducing the redundancy of the data set. So the data cleaning here will be done through four operations, which are combining work classes, then marital status combining, country combining, and dealing with missing data. Now these processes will be explained in detail by my teammate Bipul.
So, as said by Suraj, we are basically combining and removing this number of columns. We are basically combining all the data based on work classes, based on marital status. So, initially, the output which is shown, it is based on the combining of work classes. Like what is the work classes? It is federal government, whether it is local government, whether they have never worked, whether they are self-employed, whether they are not self-employed, state government, private working, business working without any payment. This is the basically all the work classes which we have, and our data is being combined based on this. These are the numbers which are shown. Like in federal government, we have 1432. For the local government, we have 3136, and there are people which work without payment, which are 21. So the first table is basically combining based on the work classes. After combining based on work classes, we have second combining based on marital status. So the different marital status are divorced, married without spouse, spouse absent, never married, separated, and widowed. These are the different marital status by which we combine the number of adults in order to get the proper prediction. Uh, this is the code for it. Now the third combining is what we have, country combining. For country combining, we have first combined different countries into specific, like for North America, we have Canada, Cuba, Haiti, Jamaica, Mexico, Nicaragua, and for Asia we have Cambodia, China, Hong, India, Iran, Japan, etc. For South America we have Colombia, Peru. For Europe we have England, France, Germany, Greece, and there are other which is south. So we are combining basically based on the regions on which they live, and like in the country which they live. Now what we are doing is we are dealing with the missing data. Like for example, for the adults which we don't have data set, we are dealing with those missing data using the command like. Now whichever data we have used the library called Amelia. Now this is actually the missingness map. Yes, can you please explain the missingness map?
As we look at the missingness map, we realize that all of the NA values are found within the occupation and working class columns only. So we choose to omit these values since there are only a few of them and will not affect our analysis.
So as you have said, we are about to omit these values using the command omit command. So once we omit all these values, we have no NA values inside, which will help better in a prediction, as the whole prediction is probabilistic prediction, obviously. So the second we have exploratory data analysis. We have a GG plot which consists of age and salaries of the adults. We have the GG plot based on age and income. Can you explain, Yash?
In the first GG plot, we have a histogram of the ages that is colored by the income. We see that the orange color is representative of all of those that have under $50,000 worth of annual income, and the blue represents those that have greater than $50,000 of annual income. Here, the coloring is indicative of percentage. From the plot, we also can see that the percentage of people who make greater than $50,000 peaks out at roughly 35% between the ages of 30 and 50. Next, Suraj, can you show us the plot of hours worked per week? Perfect. So here we can clearly see that the highest frequency of hours worked per week according to this histogram is about 40 hours per week, which has the highest frequency as shown in the histogram. We'll also look at income class by region. First, what we do is, as Bipul explained, we change the country. We block the countries according to the region. Can you show us the third plot as well, Suraj? So from here, we realize that the highest percentage of people making greater than 50,000 income is in North America, decreasingly in Asia, and then in the other regions as marked in our earlier demarcation.
So now we are training the model using the library called CA tools. We split after this split ratio, we train the model, we test the model. Like after testing the model, we break down the codes using the GLM, is a general, which means like generalized linear model. We will be using income means that we want to model using every available feature. So it's because we are predicting binary outcomes below and above 50K. Now we start with the prediction using log.model function. So here we are initializing predictions on the test data using our logistic regression model, log.model. We specify responses so that we predict probabilities instead of probabilities on the logic side. So now we have one matrix inside which is known as confusion matrix. We can compare our result using a confusion matrix since our predictions are predictor probabilities, not 100% sure. We specify probabilities that are above or equal 50% to be true and below 50% to be false. That is above 50,000 is true and below 50,000 is false. So this is the table income. Suraj, can you say show us the matrix? Yeah, perfect. This is the matrix which shows less than 50K and greater than 50K. We have numbers here. The accuracy is found using the method which, if you want to find the accuracy for less than 50,000 income, we have to add the two values and upon the total number of people, which is like 9639 plus 2116 upon values of all the four of addition of all whole matrix. Now a precision, this is how we calculate the precision. uh, Here we have some error. Suraj, can you show some screenshots? So as you can look here, we have the things without error as we have started with a different machine. Now after switching to machines, there are some issues with the code. So this is all. This is what we have predicted through our project, like income of the adults in different countries with different combining with different marital status and different work profession and different countries. And this is all the GG plots we have. Suraj, can you show the GG plots once again? So these are the four GG plots which we have got after running our code properly. This is the one more back one. This was the missingness map. The second, we have age versus the income. This is the missingness map. We are omitting it. The second, we have age versus income. The third one we have is the count of people versus hours per week, like how many people work per number of hours in a week. Then finally we have the income based on the region order. These are the four digit plots we have obtained after running our code. This was the whole project. Thank you so much. Suraj, you're not audible.
Sorry. So this was our project, and we are concluding. Hope you liked it. Thank you so much.
Thank
Thank
you
you
so
so
much.
much.